As far as yesterday, for the sub plans and stuff, you had a quiz, so I figured that took you like the entire time. And then if you had any time to finish early, a lot of you had missing assignments, so I figured you could do that. There was a 9/11 education assignment. People are saying it's not working. It works when I click on it, so I don't know why. Maybe the link is blocked on your Chromebook, I don't know. I know that you are able to access it from home. If you do it, you get a little bit of credit. If you don't, I'm not really that worried about it. I just really won't bring your grade down that much. It's like a 10-point assignment. Anyway, it's something that I have to give. It's an Arizona state law that on certain days, like 9/11, Santa Day O'Connor, and there's another one that I'm forgetting, that those days be dedicated to learning about that topic. Now, a lot of freshmen don't have history, so that's why I had to give it in some form, so you probably noticed that a lot yesterday. It's still like really important, of course, but just if you were confused, that's the explanation why. All right, so either do it, don't do it. I'm not super worried about it. If it didn't work, it is what it is. We're gonna keep moving on with what we're doing today, which is lesson 5. So first, we're starting with a which one doesn't belong. I didn't give you time to talk, which is fine. First, let's take a brief like class poll. So how many think that A does not belong? Raise your hand and keep it up. How many think that B does not belong? If B does not belong, raise your hand. How many think that C does not belong? How many? 5, maybe 6. And then raise your hand if you think that D does not belong. Okay, a bigger majority. I'll just round that to like 20. All right, so those of you that said D, why did you say that D does not belong? Kristen? It is the only one that we would consider negative. JC, do you know where you said? Okay. And negative what? Let's use our math vocabulary. Slope. Negative slope. Good. So all of these are considered linear functions. They all create straight lines. This one is the only one that has a negative slope. All right. Now, the next second most that doesn't belong is C. Those of you that said that. Why did you say that C does not belong? Or can someone maybe who didn't pick that one give me a reason why C doesn't belong? Okay. It's the only one that is dotted, as the other ones are not. So using our math vocab and everything that I write, you should probably write, maybe not the full results, but like everything else. It's the only one that we would consider discrete. All right, when the graph is a bunch of dots versus like a continuous line, then it's what we call discrete. The rest are continuous. All right, so I'll add that to the rest, even though that's not the reason that those belong, but it's the reason why C doesn't belong. The rest are what we would consider continuous. Now, what that means in this situation, well, maybe we'll talk about that another time. All right, so moving on. Only one person said that A doesn't belong. Why do you think that they chose that one as not belonging? Parker? It's the only one that starts at 0. Is there another reason? Okay, it is steeper. I would say that. So steeper. And everything that you guys are saying, there's probably like a math vocab word that you should start associating it with too. So saying it starts at 0, like 0, 0, would be the origin. So 0 on the X and 0 on the Y. The fact that it's steeper, what does that do to the slope? Does that make it like higher or lower? Makes it higher, actually. So steeper slope. If I have a slope of like 2 versus 1/2, the line with the slope of 2 is gonna look steeper than the one that's 1/2. All right, but good. Now, nobody said that B doesn't belong, but there is a reason for that one not belonging either. Nathaniel?
The dollar to an hour.
Good. They switched the titles for the X and Y axis. Are they allowed to do that? Yeah, why not? However, usually we plot what on the X axis, what type of variable? Think more general. If I'm creating a graph, what type of variable usually goes on our X axis? No. Things that are okay, well, let me give you a few examples, if I can think of any off the top of my head. Say that we're plotting like rainfall and months of the year. What would go on my X-axis? Months of the year, and how do you know that? Okay, time usually goes on the X-axis. I would agree with you there. Anyone know why time usually would go on the X-axis? Because it changes. Well, here, let me tell you. It's because it's independent. You should have said it. You probably knew it. Yes? I believe it. All right, so on the X-axis is usually our independent variable. I think of it because you can make an I with the X-axis. Technically, you also could with the Y-axis, but with the Y-axis only, I can make a D for dependent. So when we're talking about what to plot where, our X-axis is our independent variable, things that aren't affected by anything. And then our Y-axis is our dependent variable. So like what we're showing is that it looks like dollars spent or made or whatever depends on how many hours have passed. If that makes sense. All right, that's how you know what to plot with. So questions on the warm-up. All right, lots of great things revisited in this little bit of warm-up. Some of it may be reviewed, some of it you might be hearing the first time. That's okay. Just start trying to implement that vocabulary again. And a lot of it we just reviewed right now. All right, so moving on. The goal of this lesson, and I actually might have to find it because I didn't put it in the slides yet, is to graph equations into variables. So give me examples of 2 variables that you see a lot. One. Okay, X is one of them that we usually see a lot. And Y. That's going to be our main focus. Why, you might ask? Well, because X is usually our independent. Y is usually our dependent. So in a lot of these situations, you're going to see that something depends on something else. So in that case, we are going to figure out what that is and make an equation with X or Y, or maybe even other letters to show it. And we're going to graph them too. So starting with the first one. To get snacks for a class trip, Claire went to the bulk section of the grocery store where she could buy any quantity of a product, and the prices are usually good. Claire purchased some salted almonds at $6 a pound and some dried figs at $9 per pound. She spent $75 before tax. So in your groups, talk about 1 and 2. If she bought 2 pounds of almonds, how many pounds of figs did she buy? If she bought 1 pound of figs, how many pounds of almonds did she buy? Talk about that with your groups. How could you possibly figure that out? For number one, if you bought 7 pounds of almonds, how many pounds of figs did you buy? Okay, I heard 7, I heard 60, anything else? Oh, okay. Okay, so we take back the 60. Nobody else got anything other than 7, right? So let's problem solve why. Can someone walk me through how they figured out the answer for number 1? With your fingers, what did you do? All of the way up. We want to do. You're right on 9. There's a 7 when you got 53. Okay, where is this number 63 coming from? Okay. Okay, what math did you do after the 12? Like, did you just add 9 each time? Is that what you're doing? Okay. And then you had to do that 7 times in order to get. Oh, shoot, I'm gonna mess it up. Hold on, let me think for a second. Not probably. So that would be 1, 2, 3, 4, 5, 6, and 7. Okay. Did someone have like a different way that they solved it? Partner?
I did 12, 26, 63.
Okay, 12 minus 75 is 63, and then 63 what?
Divided by 9.
Okay. No problem. So only change I would make to your explanation would probably just switch these 2 numbers. But I think that's what most people did as well. Anyone have something like drastically different? So you figured out what 2 times 6 is. Most of you didn't really explain that, but you did that because the almonds cost $6 a pound. She bought 2 of them. So that's what she already spent. Subtracted it from the total and then divided the rest by what the other thing costs. All right, now what about for number 2? If she bought 1 pound of figs, how many pounds of almonds did she buy? 11. Anyone have another answer other than 11? 8. Any other things out there? All right, so let's see. The math for that, what would you have to figure out first? $75 minus 9, because she only bought 1 pound of figs. All right, my screen froze, so. Okay, that froze one. She bought 1 pound of figs, so you had to do 75, which is her total, minus the $9, which is what class? And then what did you do with the 66? Because that's how much the almonds cost. So yeah, I would agree with you. It should be 11 pounds of almonds, not 8. So make that adjustment. These 2 are correct. Now, here's like the challenge, I guess. Because a lot of the time when it comes to like the part about making equations to solve, students will be like, but Ms. Medina, it's so easy. You just do this math and you get the answer. Like, that's great. But not all the time is it necessarily going to be that easy, 1. And 2, I need to be able to have an equation that works no matter what I input into it. Okay, so you're now going to, with your groups, if you haven't already, write an equation that describes the relationship between the pounds of figs and the pounds of almonds that she bought and what she paid. Make sure that if you use a variable that you specify what that variable is supposed to represent. I'll give you like a minute or so to do that with your groups before I call on a random group. From table 7, what did you get for your equation? All right, any variations of that? Could I have other variations that are also correct? I don't know. You could have other variations that are also correct. However, I agree that this one probably seems the most logical and the most easy to create, especially for a few reasons, actually. I told you that when you have to make equations, what should you probably look for in the word problem first? Well, you will use an equal sign, but what should always be next to it and alone usually? Wait, alone? Yeah. The total, that's my suggestion. As someone who's been teaching math for quite a few years and has taken several math classes, when you have word problems, look for your totals first. Because then from there, you're just thinking, okay, what contributes to the total? She's only buying almonds and figs. This is what they cost per pound. So the more I buy, the more I have to multiply whatever pounds I buy by the number of the cost, if that makes sense. So I think that that's a great equation to make. Any questions on that? So now that well, actually a few more things about that. So on to number 4, I'm going to show you a graph that represents the quantities in the situation. It's also printed on your paper. Pick any points on the line. I would suggest one that you could clearly see, like the values that you don't really have to guess as much. Because for points like C, you probably have to estimate, is my suggestion. But choose any point on the line, state its coordinates, and explain what it tells us. Can someone remind us what coordinates like that form is? X comma Y. If we use the variables that we used before, A and F, we have A on the x-axis and F on the y-axis. So you might also see, like on your homework or on quizzes, instead of X and Y, they're using A and F. All right, but pick any point. Talk about in your groups what it tells us. And then pick any point that is not on the line, state its coordinates, and explain what it tells us. It does not have to be A, B, C, D, or E. It could be whatever. Questions on that? All right, talk in your groups. I'll assign a reporter shortly. What point did you pick for part A?
Took 0.0 and 8.5.
Okay. I would say that it's a little less than 8.5, so I'll adjust that a little bit, maybe like 8.2. So it's not exactly in the middle. But what does that mean in regards to the situation?
That's just where the graph starts, or the line.
That is where the line starts. That is my, what do you call it when it's on the Y? This part? No, origin is way down here. When it touches the y-axis, it's my y-intercept. Good. Usually any sort of starting amount in this situation is not necessarily a starting amount. But what does it mean in this situation? Maybe read the graph. 0 what? Class, do we want to help them out? 0 what? 0 pounds of almond. And then 8.2 what? 8.2 pounds, and I'll use the abbreviation of things. Could you buy 0.2 pounds of something at the grocery store? You could. Yeah. You could, that's why they have scales And usually if you do like self-checkout, you have to like put it on the scale and then it gives you an exact price for whatever it weighs. Yeah, you could buy 800 pounds of figs. That's why this is a continuous line, not a discrete line. Because you could buy like decimals of pounds. Make sense? On each end. Someone at table 1, the recorder, give me one more for part A. That you said.
2 pounds of almond for each of the ton. 7 pounds of rice.
Okay, good. So that's buying 2 pounds of almonds and 7 pounds of figs. Could I reverse it? Could I say like 2 pounds of figs, 7 pounds of almonds? Would that also be true? All right, some people say no, some people not saying anything. That would not be true. I cannot say 7 pounds of almonds, 2 pounds of figs. Why? Because when I go to 7.2, because remember, since almonds are on the x-axis and figs are on the y-axis, it has to follow that order. This is not on the line. Right? So she could not have bought 7 pounds of almonds or 2 pounds of figs and spent that amount that she said. Does that make sense? All right, well, someone else give me another example of something not on the line, table 2. Yeah, not on the line. Yeah.
So what is 2 4?
All right, so 2, 4, right here, not on the line. And what does that tell us about the real world situation, class? She could not have bought 2 pounds of almonds, 4 pounds of figs for $75. Okay. Is that making sense? So when you get to problems like that, and we've kind of seen them already before, when you get to problems on your test that say, could 2,7 be a solution? If you have a graph, or you could also graph it with Desmos, I'll show you that one day. I don't know if I'll show you it today. But you see if it's on the line, and if it is, then it's a solution to that equation that we made. And then if it's not, then it's not a solution. So an easy, like, visual representation. Questions on that? All right, so you have a U-try on the back. It's similar to what we already did. So it's another like real world situation. You're gonna figure out some values and then make an equation for it. So A, B, and C on the back side, I'll have you do. And then I'll teach you how to graph it electronically. So once you have A, B, and C done, maybe get out Desmos in some form, whether it's on your phone or Chromebook, it's fine for today. But do A, B, and C first. We have a student has a saving account with $475 in it. She deposits $125 of her paycheck into the account every week. Her goal is to save $7,000 for college. How much will be in it after 3 weeks? How long will it take before she has $1,350? And then make an equation for everything. Sense. All right, so table 3. How much will be in the account after 3 weeks? $850. Anyone get something different than that? All right, and what math did you do to get that? Because you are correct. Okay, 125 3 times. Let me move this over here so I have more room. What's a way to like I don't know, make our lives a little bit easier. I mean, that's pretty easy, math you can do in your calculator, but how else could you do this? Multiply the 125 times 3. That might be a little bit better for when we get to part C that asks for the equation. So to see like what is staying constant and what is varying each time. Okay, but good, that does give you 850. Now, table 4, how long will it take before she has 1,350? 7 weeks. Anyone disagree with that? Okay, what else do we think? 4 and 9. Anyone else other than that? 10.8 weeks. Anyone else? Okay. 8. All right, so let's see. She started with 475. So if we're trying to see how long before she has 1350, here's some math we could do. Minus the 475 first. So what math is that? 875. All right, I'm just gonna double check because in the past I've corrected people and it did not go well. All right, but you're right, it is 875. 875. Wow. 125. And why the 125? That's how much she makes in a week. So that's a good thought process. That's what we all should have done. Maybe we forgot the initial amount, I don't know. But I get 7 when I did it in my calculator. Let me double check, because again, I've been wrong in the past with my mental math. Yeah, I get 7. So that's what you should have done. Something to this effect. Now, when it comes to making the equation, think about what is staying constant each time that you should probably represent with numbers, and then what is possibly changing. Okay, table 5, give me your equation that you can help with. Okay, we got 125x equals 7,000. Equals 7,000. Yeah. Is that all that's contributing to how much she's saving for college though? Well, what else is contributing to that? Okay, now that's looking a bit better. So if it were me, I would look for the total, right? She wants to save this much for college. And then see what's contributing to that total. Let's see. What is the X representing, by the way? The number of weeks. And then, yeah, she started with some money. And then, yeah. Does anyone recognize the form that this equation is in? It's not right. I thought what it's called, but I thought the number with the X plus B or no, there's something else. Well, let me ask you this. If I wrote it like this, and then maybe I put in for 1 week or however many weeks you want, do I get different answers? I don't, so it doesn't matter. You could have the term with the X first or second. Anything else we want to add? So solving this will give me how many weeks it'll take for her to get to $7,000. However, the question asks for the relationship between the dollar amount in her account and the number of weeks of savings. So we have a value for the number of weeks. If we had to put a variable somewhere else, where would we put it? Like, where would we replace it? Well, the 475 is staying constant, so I wouldn't replace it there. I'm actually gonna move this equation down because that'll help me answer part E. But when we're just trying to show a relationship between the dollar amount she's already saved and the number of weeks that have gone by, where else should we put a variable? Where should we put this Y? I made it Y because that's usually what we use. But we need to show the relationship between the dollar amount in her account and the number of weeks of savings. We have this number of weeks of savings. Where would the Y go? In place of what? The 7,000. So I see why we thought it was the 475, but it's not the amount she started with that it asked for. It's the amount currently in her account after X amount of weeks have gone by. Does that make sense? So adjust that in part C. Now here's the fun part. Now the fun part, I don't want you to rely on as like a base. Like you still need to know how to do this stuff by hand and all that. But I will show you something in Desmos if you care to follow along and do it at the same time. Now that we have an equation and we know that equation is accurate, I'm going to type it into Desmos, the graphing calculator. And you could do this with like your own handheld graphing calculator. You just might have to look up the instructions because there's too many calculators out there for me to know them all. But if I type it in, exactly how it looks with an X for the independent variable and a Y for the dependent variable, then I get a line. Now, yeah, this line right now is showing me where my solution is, but that's my relationship between the two variables. All right, let me see. I feel like there's something wrong, but I'll have to check my book for that because it doesn't look the way I want it to look. All right, but we'll see. So you're supposed to graph your equation using graphing technology. Mark the points on the graph that represent the amount after 3 weeks and the week she has 1,350 and write down those coordinates. Okay, so the reason why it wasn't looking the way that I wanted it to look was because where it starts at originally, and I'll even show you on a different one, is like too close to the line that it just looks like a straight up and down line. So when you start typing it in at first, it looks like that, which doesn't really make sense. You could zoom out and it still doesn't really look like a whole lot is going on. What I had to do is adjust the window. So like adjust the screen. And this is how you do that. So practice that as well in case the situation arises with you. Press the little wrench. And then where it says X-axis and Y-axis, you can change those numbers to be like whatever you think is best. So like reasonably, when we're talking about number of weeks, what number of weeks should we start at? Could I have a negative number of weeks? No, so I'd probably start at what number then? 0. And then we don't actually know how many weeks we need to look at, so I picked like 55. But something like that to adjust the X so it's better to look at. We also have to adjust the Y. What does our Y represent in this situation? Money in the account. So reasonably, you could have negative dollars in your account, but we could just start at 0. And then for the Y, if we're wanting to see when she gets to like $7,000, you want to at least go up to 7,000. So I'll round it to like 10,000 just to be sure we could see it. All right, so now that's something that's better to look at. That should be more aligned with actually helping you solve this problem. Now you can do part D and E. Graph your equation using graphing technology. Give me a coordinate that represents her amount after 3 weeks. And then how long will it take to reach her goal? You could use the graph, you could do it by hand, as long as you get to the right answer in the end, that's really all that matters. So give you like 2 minutes to figure out D and E. Someone tell me the coordinate for when it's after 3 weeks. So at 3 weeks, that would be what for the X? All right, so remember our x-axis is weeks, usually time of some sort is on our x-axis. Our y-axis is money in the account in dollars. So if she is 3 weeks into her saving, how much money does she have? 850. We solved that algebraically already up here, right? We talked about that. Let me show you in Desmos how you can confirm that's a right answer. Maybe without having to do it algebraically. You can type in the coordinate. You can even label it. And if it is on the line, and you might need to zoom in to really make sure it's on the line, then it's a solution. And then that's how you write it in coordinate form, 3,850 in parentheses. Now, what about the coordinate for when she has 1,350 in her account? So 7 for the X. Good. So I'm going to put that coordinate in here just to show you, although we did figure it out algebraically as well. Do whatever is easier for you. And I'll label it for you. I'll zoom in to make sure it's really on the line. At 7 weeks, that's how much money she had. Anyone have how long it takes for her to reach her goal? Whether you did it algebraically or by looking on here, how many weeks did it take for her to reach her goal? Okay. 56 weeks. So if that's true, then I need to check that on my graph. All right, so that would be this part. Is that on my line? So is 56 my solution for that? What is my solution for that? Anyone know? Well, let's see. At $7,000 exactly, let me find that. You can also touch on the line and drag, and then that might be a little bit easier. But it has to be $7,000 exactly for the Y. And what is that X value at that? 52.2. Everyone see that before I click away and then it goes away? At 52.2 weeks is when she's saved enough. In all honesty, we'd probably have to round that up because in reality, she'll have reached her goal after 53 weeks. I don't think they're checking after 0.2 of a week. But that is where it meets. All right, so sorry it took like all hour, but the practice, I'll get into Schoology. I don't think it's in there yet. Shouldn't be more than like 6 problems max. Any questions? All right, don't lose your notes.